There are creatures that originated elsewhere, worlds. These are the untouchables. NASA, known for its basic discoveries, has confirmed that this new planet isn't just fascinating due to its size and location but also because it shows lights that appear to be artificial. Are we uncovering hidden truths that could change our understanding of the universe? Could this discovery point to life on other planets? Join us as we explore NASA's exciting findings and uncover the real story behind these baffling lights. In 2007, NASA launched the Dawn spacecraft with a mission to study the most interesting objects in our solar system. Dawn had 3 ion engines that enabled it to begin an extraordinary journey. The spacecraft's mission began with a 14-month investigation of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed images and data, revealing the intricate surface of Vesta and various land features. After completing its first target, Vesta, Dawn set its sights on the dwarf planet Ceres. Thanks to its ion engines, Dawn could depart the orbit of Vesta and travel to Ceres, a task that traditional chemical propulsion would have struggled with. The ion engines provided a gentle, continuous push, allowing Dawn to travel great distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, it is not only the largest body in the asteroid belt but also one of the most intriguing due to its unique features. As Dawn approached Ceres, scientists eagerly awaited the first clear images of this strange world. They saw bright spots scattered across its surface, particularly in a large crater, sparking excitement and speculation among researchers. Before Dawn's mission, the best representation of Ceres was a blurry, low-resolution photo taken by the Hubble Space Telescope. Scientists knew very little about this dwarf planet, and the chance to examine it closely was thrilling. What secrets would Ceres reveal? What new discoveries awaited? Dawn was expected to provide valuable insights into the evolution of the solar system and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of materials that reflect light well, possibly salts left behind by evaporated water. This raised the possibility of cryovolcanism, a process where volcanoes emit water or salty liquids instead of molten rock. But what exactly are these mysterious lights, and what do they tell us about Ceres? Could they be signs of ongoing geological activity, or something even more extraordinary? Ceres distinguishes itself from other bodies in the asteroid belt because of its size, mass, composition, and potential for water and ice. Unlike most rocky asteroids, Ceres is more like a comet, suggesting it holds more clues about the early solar system than we could have ever imagined. After 2 years of travel, the Dawn spacecraft finally started its approach to Ceres in mid-2015. This was a major milestone, as Dawn started returning humanity's first close-up images of this large object in the asteroid belt. As the images became clearer, they revealed a dotted surface with craters, pointing to an extended history of impacts. But it wasn't just the craters that attracted attention, there were unusual bright spots standing out against the darker, rough terrain. As the pictures improved in resolution, scientists speculated about the nature of these spots. Were they patches of ice reflecting sunlight? Or could they be something even more fascinating? Some thought they might be minerals or indications of cryovolcanic activity. A closer look revealed that the brightest spot was not a single feature but a collection of several distinct regions. This discovery deepened the mystery. The idea that these might be salt deposits from evaporated water gained support. This would suggest that Ceres once had, or still has, some kind of geological activity that moves water or briny liquids to the surface, where they quickly evaporate, leaving behind reflective deposits. These findings challenged previous hypotheses about Ceres, showing it to be a more dynamic and intricate world than previously thought. The presence of such features hinted at the possibility of subsurface water or pockets of salt, which could have significant implications for the potential of life in our solar system. Why is Ceres so significant? Compared to other planets, Ceres is often described as a cold planet with a tough yet fragile surface. Unlike most asteroids in the belt, which are mostly made of rock and metal, Ceres stands out because of its unique composition. Its surface is a mix of water, ice and hydrated minerals like clays and carbonates, making it less dense than its neighbors. This suggests that Ceres contains a lot of water. Its surface is rough yet permeable, with ice and other substances trapped inside. This cold nature makes it more similar to a comet than a typical asteroid, hinting at a past that might have included both rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more intriguing aspects of its structure. The dwarf planet is thought to have an interior with layers, a slushy mantle and a core. The mantle is believed to be packed with water ice, making up about half of Ceres' total volume. This icy layer, possibly mixed with rock and salty water, surrounds a denser core, potentially made of silicates. The large amount of water ice suggests that Ceres might have had liquid water, particularly if its center was heated by early radioactive decay. This structure sets Ceres apart from other asteroids and raises interesting questions about its potential for geological activity and the role of water throughout its development. In addition, the discovery of ammonia-rich clays on Ceres suggests that it might have formed in a colder, more distant region of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, strengthening the possibility of a subsurface salty ocean. These findings not only broaden our understanding of Ceres but also offer key insights into the formation and evolution of icy bodies in the solar system. Cryovolcanism is an intriguing geological process, quite different from the volcanoes we see on Earth. While regular volcanoes erupt molten rock, cryovolcanoes, also called ice volcanoes, release substances like water, ammonia, or methane in liquid or gas form. These materials can survive in cold environments like Ceres. Cryovolcanoes work by allowing water mixed with salts to rise to the surface. When this salty water reaches the vacuum of space, it rapidly evaporates, leaving behind bright, reflective deposits of salt. The most famous of these bright spots is located within the Orcator crater, specifically in a region known as Spot 5. This area has drawn significant attention due to its unusual brightness and the presence of transient fogs, as observed by the Dawn spacecraft. The fogs are thought to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing, or may have occurred recently. Ceres has multiple bright spots, each with its own unique properties. These spots are spread across the dwarf planet, implying that cryovolcanism might be a widespread process. The outer surface of Ceres is covered in craters, each revealing clues about its history and evolution. Some craters display signs of slumping, landslides, or even central peaks, suggesting that the surface may be more dynamic than previously assumed. Scientists have observed ridges, fractures, and grooves, hinting at possible geological activity in Ceres' past. One of the most intriguing surface features is Ahuna Mons, a dome-shaped mountain that stands about 4 kilometers, 2.5 miles, high. Unlike other features on Ceres, Ahuna Mons appears relatively young, as it lacks the extensive cratering seen elsewhere. Scientists believe it may be a cryovolcano, one of the clearest indications that Ceres has experienced recent geological activity. The presence of a cryovolcano on Ceres supports the theory that briny water or slushy mixtures of ice and salts have erupted onto the surface in the past. This further reinforces the idea that subsurface water may still exist, potentially making Ceres a key location in the search for extraterrestrial life. What do the bright spots reveal? The bright spots on Ceres, particularly those in Orcator crater, have been analyzed in great detail. Spectral data from the Dawn spacecraft indicate that these spots are primarily composed of sodium carbonate, a type of salt that forms in water-rich environments. This suggests that liquid water may have once existed beneath Ceres' surface, occasionally seeping up through cracks or vents before evaporating and leaving behind these reflective salt deposits. More remarkably, some studies suggest that certain areas of these bright spots could still be interacting with the environment. Observations of haze-like formations over the crater suggest that sublimation, where ice transitions directly from solid to gas, may still be occurring. If this is true, it could mean that Ceres has an active water cycle, albeit a weak one compared to planets like Earth or Mars. The possibility of life on Ceres. Could Ceres harbor life? While it may not be as hospitable as Mars or the icy moons of Jupiter and Saturn, Ceres presents a compelling case for astrobiologists. The presence of water ice, salts, and organic compounds, all key ingredients for life, suggests that, under the right conditions, microbial life could have existed in the past or even persist in isolated pockets today. If liquid water once flowed beneath the surface, Ceres may have hosted environments similar to Earth's deep-sea hydrothermal vents, where life thrives despite extreme conditions. Even if life never developed there, studying Ceres could provide crucial insights into the chemistry and processes that shape habitable worlds. The legacy of the Dawn mission. The Dawn spacecraft continued to study Ceres until it ran out of fuel in 2018. Instead of crashing into the dwarf planet, it was left in a stable orbit, where it will remain for decades. The data collected by Dawn revolutionized our understanding of Ceres and its place in the solar system. Dawn confirmed that Ceres is far more than just another asteroid, it is a complex, evolving world with a rich history of water activity, cryovolcanism, and possibly even prebiotic chemistry. Future missions may further explore Ceres, perhaps drilling into its surface to search for signs of past or present life. As we continue to explore our cosmic neighborhood, Ceres remains one of the most intriguing destinations. Could it hold the secrets to the origin of life? Only time, and further exploration, will tell. Planet's history. Some craters are shallow and worn down, showing an old surface that has received numerous influences. Those that last for billions of years are preserved better, with sharp edges and deep bowls indicating more recent impacts. Interestingly, there are fewer craters in a series that were not anticipated, which could indicate that geological processes are resurfacing the planet, erasing older impacts. One theory is that Ceres' icy surface permits cryovolcanic resurfacing, where subsurface materials rise and conceal previous features. This ongoing activity suggests that Ceres is not a world that is still, but one that has been, and may continue to be, changing. Further surface deformation evidence on Ceres comes from cracks, ridges, and faults, showing that its crust has been under stress. Some of the cracks appear relatively young, perhaps just a few 100 million years old. These features indicate that Ceres possessed internal heating, perhaps from tidal interactions or radioactive decay from nearby celestial bodies. The signs of bright spots, surface deformation, and craters exhibit that Ceres has gone through a complex history of geological processes, including the possibility of past or ongoing cryovolcanism. These discoveries aren't just important for understanding Ceres, but they also broaden our understanding of planetary evolution and the potential for life beyond Earth. Surface and subsurface water hold the secrets to extraterrestrial life. While the evidence is not yet conclusive, it is evident that the world of Ceres is full of surprises, with mysteries still waiting to be resolved. In the end, the bright spots on Ceres offer a fascinating glimpse into the dynamic and complex nature of this dwarf planet. With its potential for cryovolcanic activity, subsurface water, and ongoing geological resurfacing, Ceres is much more than a frozen remnant of the early solar system. It is a constantly evolving world that challenges our assumptions and opens new doors for exploration. As spacecraft continue to send back data, they may still reveal additional secrets hidden beneath Ceres' icy surface. Figuring out the mysteries of Ceres is a journey far from over. The Dawn spacecraft may have completed its mission, but its discoveries will always shape our understanding of the solar system and the possibilities of life on distant worlds. At the conclusion of the Dawn mission's primary phase, it left behind a legacy of groundbreaking data that will fuel scientific inquiry for years to come. The series of discoveries made by the spacecraft, particularly the intriguing bright spots and evidence of geological activity, changed our perception of minor planets in the solar system. But what lies ahead for future missions exploring similar icy bodies? Scientists are eager to extend the knowledge gleaned from Dawn's investigation of Ceres. The possibility of subsurface oceans, or at least pockets of liquid water beneath Ceres' icy shell, has sparked fresh interest in how life could exist in such harsh conditions. Water is one of the key ingredients necessary for life, and the possibility of liquid water beneath Ceres' surface presents exciting opportunities. If microorganisms could flourish in a similar icy environment, it may provide us with a glimpse into the future of life on other moons or planets with subsurface oceans, such as Jupiter's Europa or Saturn's Enceladus. The question of life beyond Earth has fascinated scientists, philosophers, and the general public for millennia. With increasing interest in astrobiology, the study of the potential for life elsewhere in the universe, data gathered from missions like Dawn help narrow our search for extraterrestrial life. Ceres, with its mixture of rock, ice, and salt, could provide essential clues to understanding how life might arise in other parts of the universe, even in places once thought inhospitable. As we look ahead, future Ceres missions, along with discoveries of additional icy bodies in the solar system, will build upon the foundation laid by Dawn. While the Dawn spacecraft's mission has ended, its impact continues through the ongoing analysis of the data it provided. In the coming years, new technologies may offer even more precise images of Ceres. Future spacecraft could land on or orbit comparable worlds to gather samples and conduct further research. Ceres is not a unique case in the search for habitable environments. The fascination with Europa, Enceladus, and even Pluto's Charon demonstrates that numerous other bodies in the solar system may support conditions for life, or at least contain the building blocks for it. The lessons learned from studying Ceres could be invaluable in helping scientists determine the most promising targets for future exploration. Beyond the search for life, insights gained from studying bodies like Ceres can also help us comprehend the formation and evolution of our solar system. As a relic from the early solar system, Ceres provides a snapshot of the conditions and processes that shaped planets and their moons. Understanding its unique characteristics, its icy surface, salt deposits, and potential for cryovolcanism, helps piece together the larger story of our solar system's past. This information may reveal hints about the material composition of the early solar system, the role of water in planetary formation, and even the development of new planetary bodies. With advancing technology and a continued interest in space exploration, we are only beginning to uncover the mysteries of icy bodies like Ceres. As we probe deeper into these enigmatic worlds, questions about their potential for sustaining life and their role in the history of the solar system will continue to inspire scientific curiosity and innovation. Ceres may have started as a distant, unknown dwarf planet in the asteroid belt, but thanks to NASA's Dawn mission, it is now a world of incredible scientific significance. The bright spots on its surface are just the beginning of what promises to be a new chapter in our exploration of the cosmos. As we continue investigating this fascinating dwarf planet, who knows what new discoveries lie ahead? The journey to uncover the secrets of Ceres, and the many other worlds like it, has only just begun. To continue exploring Ceres and its significance, scientists are looking toward the next generation of missions. Future spacecraft equipped with more advanced instruments could analyze its surface composition in greater detail, probe deeper into its subsurface, and perhaps even land on Ceres to collect samples. Such missions could confirm whether liquid water exists beneath the icy crust and whether any conditions necessary for life are present. One of the most exciting possibilities is sending a lander or even a drilling probe to Ceres. A surface lander could directly analyze the bright spots, testing their composition and determining whether they contain salts, ice, or even organic compounds. A drilling probe could penetrate beneath the surface, revealing whether liquid water exists in underground reservoirs and providing crucial data on Ceres' geological history. In addition to robotic missions, there is also growing interest in using telescopes to monitor Ceres from Earth and space. Observations from powerful telescopes like the James Webb Space Telescope, JWST, could help detect changes on Ceres' surface over time, providing insight into ongoing geological processes. Beyond Ceres, the study of icy worlds continues to expand. Jupiter's Europa and Saturn's Enceladus, both of which have subsurface oceans, are prime candidates for exploration. NASA's upcoming Europa Clipper mission will study Europa's icy crust, searching for signs of habitability. Similarly, future missions to Enceladus could analyze its water plumes to detect organic molecules and potential biosignatures. Ceres is a vital piece of this larger puzzle. As the largest object in the asteroid belt and a possible example of cryovolcanic activity in the inner solar system, it provides a bridge between our understanding of rocky planets and icy moons. It challenges the traditional boundary between asteroids and dwarf planets, showing that even in the asteroid belt, geological activity can persist over billions of years. With every new discovery, Ceres reshapes our understanding of planetary evolution. Its bright spots, surface fractures, and potential liquid water suggest a world far more dynamic than previously imagined. As technology advances and new missions are planned, the mysteries of Ceres will continue to unfold, offering fresh insights into the origins of our solar system and the potential for life beyond Earth. The story of Ceres is far from over. While the Dawn mission provided the first detailed glimpse of this enigmatic world, future exploration will build upon its findings, pushing the boundaries of what we know about icy bodies in the solar system. In the coming decades, as space agencies and private companies expand their reach beyond Earth, Ceres may become a key target for further study, and perhaps even for human exploration in the distant future. The journey of discovery has only just begun, and Ceres remains one of the most intriguing worlds awaiting further exploration.